So as advertised, this section is about, next slide. Communications control and interoperability. Not so much the details of how you translate prices to functional control, but where the control happens and how that information gets communicated around. We've got an excellent panel of people who have diverse roles in this ecosystem, and there's a lot of different moving parts to this. And so actually, next slide. So Stephen, who will, everyone will introduce themselves a little bit later. Renew Home is a cloud-based optimization service. Universal Devices makes a hardware device that sits inside of a house and represents, it works for Silicon Labs, but has an important role in the Matter organization to promote that standard and develop it. And then my role is with CalFlexHub on our task 5, which is all about communications control and interoperability. So next slide. So Stephen.
All right, so I was told we're going to start at the podiums. And the kinds of services that we want, and for that sort of mass market user. And so I think that's like one of the lessons I've had over the years. That means that we really have to kind of focus on making this easy for people. And so it's like, if you want to achieve that thing where we're going to get, you know, half of the homes in California to be responsive to dynamic prices, then it has to basically be something that people don't need to understand IT. They don't need to understand market dynamics. They don't need to understand any of these things. It just kind of needs to work. And, you know, I think it would be wonderful if we had dynamic prices. It's maybe a little slightly challenging for like the business model of a company like Renew Home. We can talk about that. But I think it addresses a lot of problems that we have. So I think it could be really, really pretty exciting. And so I think that's kind of like the last part of it, is just that it can really work, but I think the user journey is challenging because of all the reasons that I outlined. And I look forward to talking about that with the rest of the panel and with all of you. Who's next?
Yeah. Next up, Orly.
Thank you. Hi, everybody. I'm Orly. I'm with Universal Devices, and I'd say I'd wear many hats as well as does Universal Devices. We are a software and hardware development company. Our customers range all the way from the average homeowner, or maybe the more technical homeowner, to lighting controls and manufacturers of various devices within commercial spaces, and all the way to utilities. So Albert Chewy was here, and Eva Molnar. Great relationships. I think I love working with the different types of customers, and having been exposed to all of that puts me in a position of, how do I optimize all of this to help Universal Devices with what they make? And at Universal Devices, really, we had a vision from the beginning of an open source platform. We believe in creating a platform that integrates all devices. And I know it sounds extremely ambitious, but that's our goal. And it's regardless of a manufacturer, regardless of a communication standard. So I'm excited. We're going to hear a lot about Matter, and we look forward to, implementing Matter within our device, and we already have part of it there. But it really is inevitable that there's going to be different standards out there and different devices using different standards. So all the way from Modbus and SCP and Zigbee and Z-Wave and now Matter or Thread. So a lot keeps changing. And the way we see this happening is not just by universal devices creating something and owning all of it. We really see this as an open ecosystem, if you will. We have over 150 third-party developers. They create the plugins to the different devices that are out there. So we have a guy in France who created the integration or the plugin for the Tesla Tesla vehicle. We have different people that create them based on needs. They'll send us the code, and we have a store that we list them. And if you will, it's similar to having an app on an iPhone or an Android. So that's our vision. That's how we see this becoming scalable. People have the EV in the house, the heat pump. They have, the pool pump. There's the HVAC. We don't see this as one manufacturer's controlling, a specific device, and this is how it's going to work. So we've worked with dynamic prices for the last 7-8 years, all the way from a CEC grant to a phase 1 with Southern California Edison, and now, phase 2. We believe there is an overall, if you will, brain that needs to process all these different inputs. And at different sites, the priorities are different. So we see our platform, creating that seamless integration. We don't want the customer to change the devices if they don't want to. We want to be able to talk to whatever device they already have. Also, we want to take their priority into consideration. Whether it's a house and the pool pump, can't run at certain times of the day, but the dynamic price, suggests they should. We want to take that into consideration. And maybe there's another house where it doesn't matter when it runs. So that's great. Or if it's a facility, a commercial or industrial facility, and the way they run their operations is a certain way, our platform takes into consideration that customer's priority. Otherwise, I agree with what Renew Home just exposed. It has to be simple for the customer and for it to be truly scalable and adoptable to make a large impact. And again, that's our vision, being able to create a platform that takes in all devices, all manufacturers, and all the different standards, the ones that exist and possibly the ones that, will be coming down the road. Thank you.
Hi, my name is Anne. I work for Silicon Labs. Yeah, can you guys hear me okay? Silicon Labs is a silicon provider. We focus on wireless connectivity for the IoT. So we provide hardware, software, and IDE, other development tools, and as well as ecosystem support. So we work very closely with the ecosystems, especially around Matter, but also other platforms like Amazon Sidewalk, and so on. My role within the Connectivity Standards Alliance, the CSA is a group of companies that builds all sorts of different connectivity standards. So they used to be known as the Zigbee Alliance. Now they've got a number of working groups, including Matter, Product Security, and Alira, which is a access control standard. You can see the board member companies here. So these are some of the companies that you can see who are driving the Matter standard from the board of directors level. And my role within the Matter work group is I am the marketing and product subgroup vice chair. So what that means is within the working group, I'm working with companies to define market requirements and product requirements for the specification. Then they go into technical work, they go into certification work. And then on the other side, I work with our outbound marketing teams to explain to the world what it is that we actually built. Next slide, please. So I'm going to take you through a couple slides on the Matter protocol. If you're not familiar, it is a single IP-based protocol at the application layer. It works over Wi-Fi and Thread. And the main goal for us was really to simplify development for product manufacturers. We found that, one of the challenges was that, a manufacturer would build a smart bulb, for example, and they would have to build it multiple ways to adhere to those different connectivity standards. So Matter is trying to unify all of those things as well as connecting to that ecosystem support. Next slide, please. So the Matter specification launched in October of 22. So we're about 2 years old now. At version 1.0, we introduced a number of kind of the traditional smart home devices, door locks, motion and contact sensors, lighting, thermostats was part of version 1.0, as well as other devices like blinds and shades, smart TVs, and garage door openers. Moving into 1.1, we announced some specification enhancements and other developer tools. But then moving into 1.2 in October of last year, we introduced a whole slew of appliances, excuse me. So we had our bigger kind of energy using appliances like refrigerators and dishwashers, air conditioners, fans, etc. 1.3, we announced officially like our first energy management support. So EV charging supply equipment, as well as energy reporting and energy management options. So this was kind of the first iteration of that. If you look closely at this timeline and you're good at recognizing patterns, you might notice that we are due for another specification soon. We will be announcing Matter 1.4 soon, and you'll notice some new device types coming down the pipeline that we've created support for, including heat pumps and water management. Next slide, please. So here's just kind of a recap of the devices that are supported by Matter today. I don't know that I really need to say much more than that, other than this was a pretty slide and I wanted to show you guys. Next slide, please. And then so to wrap up, I think, I'm right at the end of my time anyway. I wanted to share some trends. You know, we've been kind of talking the panelists in preparation for our discussion today, talking about some of the demands. And I'll highlight, if you kind of come to the center of the screen, a recent survey found that 79% of consumers they reported that saving money on energy bills is a primary motivation for them to actually purchase these smart home products. So the Matter work group, when we're building the specification and building the standards, we're really looking to what are the market demands and what are consumers really interested in purchasing. We want to build to that kind of stuff first, rather than just building what we hope they might buy. So we see that there is market demand for it. And yeah, looking forward to the discussion with the rest of the panelists today. Thanks.
Yeah, so I want to give you a little bit of context on the CalFlexHub view of this topic area. So my work is mainly on what I would say is system architecture and the communication protocols that support that. And by system architecture, it's about what entities actually exist, what are they called, and who talks to whom about what. And that nicely summarizes what we need to do. So this covers everything from when the price is announced by whoever's selling the electricity, the retailer, to the final device that is actually changing its behavior. And I want to give a shout out to Australia, where they've started using the term customer energy resource for things that are located inside of customer premises, to remind grid people that it's the customers that own it and control it, and it's supposed to be on their behalf. It's not the grid's resource. I drew up this diagram 4.5 years ago, and I have changed it 0 times since I originally drew it, which I'm very proud of. And this is not the simple version. There's a complicated version somewhere else. This is the only version of the diagram. This is the whole thing, because we need to have things be simple if they're going to be effective, scalable. And finally, all the green arrows on the line, which are carrying prices, can be served by OpenADR3, which can carry both the wide area communication from the grid to the customer site, as well as the intra-customer site communication, which is going to be increasingly important. Next slide. So to sort of zoom in on this, the price isn't directly what we want. We want devices that change their behavior. So some device needs to translate from the price to the functional control decisions. And that could be any of the 4 entities at the bottom of the screen. Ideally, it's the device itself. A year ago, my phone got a software update. It's now grid responsive, and it responds to a marginal greenhouse gas signal. If that was a price signal, it would be price responsive today. Undoubtedly, many of you in this room have your phone is grid responsive. It's been that way for a year, and you didn't even know it. And it was free. My heat pump at home is controlled by a controller, which is also operating on hourly prices, which sadly I cannot pay, but it's optimizing to our CalFlexHub prices. And then Matter can implement all of the arrows inside the customer site, both carrying prices. Well, it doesn't carry prices today, but we can expect that in some future update. And of course, the functional control signals. And so that'll be increasingly important. Not all devices will Matter, but I think a lot will be, and that'll be a critical part of the future. Next slide. So just to clarify what we're talking about here, I don't use the term real-time price because that's a wholesale market construct, and we are talking about retail prices. We're not talking about wholesale prices. And we don't even want to calculate the retail price from the wholesale price directly. That's another topic for another day. So the intervals are got to be somewhere between hourly and 5 minutes. That brackets the range of what's reasonable. My smart meter can only measure 15-minute intervals, but we may get to 15 minutes and decide it's not worth going to 5. I think as we get more storage, we may well determine that. And it needs to be set no farther advanced than the day before and different every day to be responsive to actual grid conditions, because if it's not, it's the wrong price and you get the wrong result. And then, so what do you actually need to communicate? You need a forecast out for like at least the next 24 hours so devices can plan. You may, as some California customers have today, an export price, which is different from the import price. And so that affects what we call the local price to optimize to. And then 2 non-financial elements, which is the marginal GHG signal and occasional emergency alerts. Hopefully they're less often than more often. And then critically, we do need to coordinate capacity between the grid and the customer, but that's also a topic for another day. So next slide. So we think we're at the leading edge because we're planning to have such prices in a few years. There are such prices available today in at least 19 countries, okay? Now, the number of people who use them varies dramatically from very few in the US to most people in Scandinavia. They are on hourly prices because they result in lower bills than the alternative. So that's the key to success, is ensuring that people save money. And pricing is the only mechanism which can work in any context, in any country, at any scale. So the wireless access points up there are powered by Ethernet, and the cameras back there are probably also powered by Ethernet. You can carry up to 90 watts on an Ethernet cable. You can put a price for the value of electricity on this wire, not according to an application layer protocol, but according to the Ethernet standard itself. So that's using prices at that scale. We use prices in whole scale markets, and there's about 1 billion times difference in the amount of power on this cable as in the wholesale market. And I challenge you to think of mechanisms which can operate over 9 orders of magnitude seamlessly. So next slide. And now we're on to our discussion. And so I'll ask some questions, and I might chime in myself a little bit. So the first question is, what are some key needs that we have to make price-based grid coordination move forward successfully? Who wants to start first?
Yeah, so I think one thing that we need are devices that are able to participate. And I think, Matter is playing a role in trying to bring that forward. But I have found that there's a challenge of getting OEMs to actually produce devices that say, like, include Matter connectivity. And so the Nest thermostat is the only major thermostat manufacturer in the United States that provides Matter control in the 2 products that they currently sell. So why aren't the other manufacturers on board? And I can't say for sure because I've never worked there. But I think there's a work for us to do to figure out how we're going to get the device OEMs over the hump to include the kinds of connectivity that we need so that we can get controls. Standards is part of it, but there are other pieces that we're going to need to talk about, and those would be some of the barriers.
Yeah, I think, we're talking about prices to devices, and I think that's one approach, but our approach, or the way we look at it, is a little bit different. We think there's a little more coordination that needs to happen, and the fact that a price will go to one device and only that device will respond, or that category of devices, it's just not enough. That has to take into account the customer's input, the customer's comfort level, the customer's priorities, and there has to be some sort of orchestration happening. So, yes, it's the OEMs and having the devices, even having the capability to take price into consideration, but nobody's going to change everything, and it's going to take a while till we get to that point. But even when we do, I think that that overall orchestration and prioritization and comfort and input from the customer, depending on the type of location, has to be taken into account.
And I think to piggyback on what you guys have said as well, there's a challenge within Matter, I think, for any device type, not just energy management, that, device manufacturers are afraid of being commoditized, right? If we're all going to adopt the standard, then like, how do I stand out from my competitors? And I think our message is that we're trying to standardize on this piece so that y'all can do the innovation on top of it, right? That like now we don't have to argue about how to do plumbing anymore. Like we've created that, right? Now make a really nice toilet. Sorry for that analogy, but but that's kind of the point of standards, right? So kind of creating that baseline so that we can innovate on top of it.
Yeah, so standards provide a floor, not a ceiling. And I'll just add from my own perspective, the biggest barrier, the biggest need is to have tariffs so that people can actually pay these prices. Because if you have prices but no devices that are automated, you can do things through manual behavior and simple timers. But if you have devices and no prices, you can't do anything at all. So for the next question, why don't we talk about what are some of the key barriers that need to be overcome to also make this successful? And I realize there's some relationship between needs and barriers, but
I think immediately everybody thinks about legacy devices, what's already out there and what people have in their facilities. So whether it's a building or a home, or people have what they already have, you're not going to necessarily go in there and force them to take something out. One of the speakers earlier today mentioned, they buy these devices, they put them there till they die and they replace them. But I think that's changing, especially when you talk about thermostats, and people are willing to try, if the investment is not very high, new devices. But again, we look at it from the other side, where we want to put something that's between the device and the price signal. We want to put that layer in there. So that's where we come in and we offer that solution.
Yeah, I think another barrier, at least from our perspective, is actually getting people together and actually doing the work so that we can implement this future. We've got a couple really active companies who are working on energy management in particular right now, but maybe it's a handful, right? It was not like this huge slew of experts working on it. So I think that's one challenge. And then I think in terms of barriers, like we've seen recently, just in the smart home industry, maybe 2 years ago, 5 years ago, the people that were buying smart home devices, they were looking for kind of these, quirky, I want to change the color of my lights with voice control kind of use cases. The smart home has evolved since then, and studies are showing that consumers are more interested in buying devices that are going to create new experiences for them and make their lives better. We don't really care about automating lights anymore. I mean, it's kind of, I guess, given at this point. But consumers are really interested in creating these, in having their smart homes kind of create these new experiences for them. And interestingly, energy management is the use case that comes out as one of the key drivers for buying these kinds of appliances. So, it's kind of a chicken and egg problem, I think, where, how do we get manufacturers to implement this technology that they could take advantage of the flexible control? But then how do we market to consumers that this is something that they might actually want to, maybe you want to spend a couple $100 more on this Wi-Fi connected dishwasher because it's going to allow you to save XYZ percentage, which I think we would look to the folks in this room to give us some of those stats.
Yeah, I definitely agree with what you all have said so far. And I think that there's a couple barriers that are worth noting. So one is just, like I said, getting the devices. And I think part of the problem is that I think everyone would like a slice of the pie and, would like to figure out how they're going to earn through this mechanism. And that goes for, the users ultimately are the ones that want the service. And the user should benefit from not getting the full service that they want exactly how they want it. So there should be some savings for the user. The device OEMs are supporting their cloud platforms, which cost money in order to manage these devices and provide ongoing software and security updates. It may not seem like that is significant. I can tell you doing that at scale costs actual money. And so you have to pay for that somehow, because otherwise it is just a loss center. And so the device OEMs would like something. And then I also think that some device OEMs have an outsized imagination of how much money is available for load shifting their dishwasher, for example, which is there's not basically any real value associated with it. I mean, there may be a little, but there's not a lot, right? So I think that's true. I think another barrier is just user acceptance. Like I said, I mean, we at Renew dispatch millions of load shifting events every day. And we do it with a very, very low opt-out rate. But we do that because we have accepted where the users are, which is that they're not interested in deep discomfort. They're not interested in something that they need to engage with deeply on a daily basis. And so we're able to load shift really large amounts of energy by doing it in a way that has user acceptance. And so I think that's another big barrier, is how do we get users to accept it, to set up these devices, to set up this capability, and then to stay with it.
I actually want to echo that as well, because I think it's a user journey too. Customers are now just getting used to time of use. And this is a whole other paradigm for them, dynamic rates. I mean, whether it's a large customer or a small customer, this is now a new way of looking at their consumption of energy. So no matter how big or small, now there's going to be, it makes an impact and it adds up, especially if you're, a small, medium business, you're a McDonald's that's trying to, all costs are going up. How do I manage my electricity possibly a little better? So to try to mitigate or try to lower that rate. So I think the customer journey is one of the barriers as well. How do you translate this to something that is simple enough and adoptable by the customer, and they want to invest, or they don't have to put in a lot of time into it. They shouldn't have to. But what technology is going to have to come up with is solutions that are simple enough, that provide value enough, that adds up or translates it to dollars and cents, that makes sense to a customer. And then if I know that by changing a certain behavior or flexing, if you will, I'll be saving this percentage on my bill or this amount of dollars and cents, I'm more likely to participate and actually stay engaged.
Yeah, and I'll just say that, again, the major barrier is the lack of tariffs, but another one is the lack of harmonization across utilities, not only nationally, but globally. With IT devices, we're familiar with technologies being used everywhere on the planet, USB, Wi-Fi, et cetera. Electric utilities are accustomed to doing things differently everywhere and differently with different customers and changing it over time. And that's not scalable to make things work in an automated fashion. And manufacturers need to be able to implement it once and sell it everywhere. That's got to be the future.
I have one last thing I'm going to say, because I think this is a barrier and it doesn't just apply here, which is access to energy data is just a huge, huge, huge problem. So if you want to access the meter data from homes across the country, I mean, even if you want to do it in California, and we have the best possible infrastructure for this in this state due to regulation, it's really, really hard. And Green Button Connect is great, but it really doesn't result in uniformity even across the California IOUs. Across the country, it's even much, much harder. So just getting access to energy data is necessary. If you want to optimize, you need to have the data to optimize on. And so it's one thing to get some data from individual devices and to get prices, but there is another aspect that we also need.
I would love to piggyback on that, just to add a little bit more, because you got us started. The same research that I was citing before from Parks Associates, interestingly, they found that the energy data piece was like the one piece that consumers really wanted. Whereas, a couple of years ago in the smart home, it was all about automations and it was all about doing this stuff and I think what we're talking about here on stage is that, we do want to automate some of this, but what they're finding too is that smart home consumers really want to be able to manage their own stuff. They want to look at that data and they want to be in charge and making their own decisions. So again, I think opening up that data for consumers is going to be key.
Yeah. So after you address data. Why don't we go to some customer questions?
Sounds good. So I want to say on my first pilot or dynamic rates that this is 7 years ago, there was actually a form that customers had to physically sign. It was a scissor form. They had to sign that they're giving us permission to have access to their data. Thankfully, things evolved and now we have green button and utility API, and there's a lot of effort to clean data and have it more available. But still, it definitely is an issue. Who controls that data? So if a manufacturer puts a thermostat in a house and they store the data to your point, and it costs them money to do that, they want to recoup the money, but then maybe the fees are large enough, so large that it's harder for other vendors to use that data or purchase that data and try to make some optimization. I mean, I hope AI, I hope it gets cheaper. I hope AI helps develop, better models and better opportunities for optimization. And that's how I address that barrier.
Great. So why don't we take at least one question here and then see if there's a question online.
Thanks, Kula. Denver Hines, SMUD. Curious to your thoughts. We've talked about protocol standards at devices being communicated with by parties other than the OEM, presumably. The OEM provides the product with a cloud-based service and manages the software on the product and some of the services to the product. We also talked about the cybersecurity relationship they have with the product and these protocols. I'm curious on your thoughts if the OEM service goes away and there's still a protocol in place on that device for other parties to interact with. Your thoughts on the long-term sustainability and functionality and cybersecurity of that protocol as implemented on that device at a point in time and being accessed by third parties, presumably through the internet. What are your thoughts on the viability of that protocol over the long term if it's essentially a piece of hardware when the OEM service is disconnected, if?
So again, our approach to it is as long as we can, we will support what we provided to the customer. So we have customers that have our box for over 15, 16 years, and we support everything that we promised them when they purchased the box. The only hiccup we ever had was during COVID, because some of the hardware just became unavailable, and we had to reach out, for the first time in our history at least, reach out to customer and say, you know what? It's going to be very difficult to continue providing all of these because possibly chipsets were not available and we just couldn't provide everything we used to provide. So at least from where we come from, if we delivered it to a customer, it should, as long as possible, continue functioning. Again, though, if you look at technology, things do evolve. The products do reach some sort of a life cycle end, and there's their renew. I mean, still people that run X10 if you're in home automation, and we still support it. If you build it and it stays standard, I mean, the standard doesn't change. The product should still continue supporting it.
I do think this is one of the advantages of these local communication protocols like X10, for example, or Matter. It's that because, if you have a device and it supports, Matter 1.3, then that device will support Matter 1.3, until it dies. I can also say that maintaining cloud connectivity to old devices across security challenges is a big deal. And, I've never worked with devices that have been in the field for 15 years, but at Google, we did have some of the Nest thermostat, the first generation of the thermostat that we had to maintain and continue to maintain. And it is a real challenge. And, providing that connectivity under, modern security standards is really hard. So I think that moving towards local communication is a big piece of that. And I think the device OEMs are going to have a very hard time giving up that cloud access despite the costs that they incur for it. But I think local communication can really make a big difference.
And I can speak a little bit to kind of how we handle it on the Matter side. So the the way that the CSA manages their certifications is through a distributed compliance ledger. So any device that goes through that certification program, you have to add your device to this DCL, and it's going to be hosted on multiple nodes throughout the world. So anytime within a Matter network, if a new device is commissioned, it's going to talk back to the controller, and the controller is going to reference the DCL and tell you either like, yes, this is a, this, you're good to go. Here's a real Matter device, or you're going to get a warning with whatever ecosystem you're commissioning it on. So we've seen this with some like demo devices that you might get a warning like, hey, this isn't really a certified device. Are you sure you want to add it to your network? So I think that's one piece. But again, that's just protocol security. That's not even thinking about device level security, which is a whole other ballpark.
Question from the ether?
Yeah, so we've got quite a few.
I think one.
All right. Oh, one. They're all really good. All right, I'll editorialize. Okay, this is a great one. What is the grid impact if every device in a given network were to respond to a price in an identical way?
I love it.
Okay, we're running really short on time.
Do you want to
And-
take that? I mean,
Well, just be brief and also maybe answer how do we pay for flexibility? Like with one
I will let you handle the payment part. I don't like that part. But I would tell you, I completely agree. That's why I, or at least the universal devices, we don't see it as simple as prices to devices. It can't just be like that because, I mean, the impact could be pretty dramatic.
Okay, so yeah, there could be instability in pricing if you had really large responses, right? The price could be unmatched from demand. So you have to consider that in your design and consider the design of how you do pricing to take that into account. Or you could consider transactive approaches. That's another alternative. Bruce asked this question about how do you pay for this? And I think that we have this long period of time where cloud service providers are going to be important. Most of these devices are going to be cloud to cloud integrated and not locally integrated for a very long time. And one option would be to have people sign up for a service provider that would then be paid for along with their utility bill. So you could call that like on-bill financing, for example. You sign up for a provider via your LSE, your load serving entity, and then you could pay a service provider to do that. And I think that could help bridge this gap and help finance some of the costs associated with maintaining all the infrastructure that we need in order to get there.
And for what it's worth, we're already seeing this trend with other smart home services through like an ISP, for example. So folks or consumers are willing to pay a little bit more on their bill on a monthly basis to have security services, for example. So it's been done, and it seems like that could be a good option moving forward.
Yeah, and just to echo actually both points Stephen made, if you don't want to get a sharp discontinuity in demand, don't have a sharp discontinuity in price. That seems pretty obvious. And I want to completely endorse this on-bill payment because I think that's the simplest way for everybody to make sure that things can get paid for appropriately and transparently. So I think we're out of time. Is that right? Okay. The last word here.
So I have a complex question. One question is when you think about dynamic pricing, how you think about how this compares to VPPs, virtual power plants, and could you imagine being in with price response and other emergency programs on top of that? Number one, that's the first question. Second question is about data privacy, because a lot of people are concerned with devices that are collecting information about them, and how do we address that?
I'll just start by saying that I think pricing is higher performing and lower cost than VPP, so it's a great combination. But we're for the foreseeable future going to have both, so we need to make sure that technology fully enables both. So as long as we have fair coexistence.
I agree with that. I think we built the same van that we use that I show here. This is a home automation, gateway, if you will. This is the demand response virtual end node. This is the same box that took in the dynamic price, processed it, and sent the signal to devices to change how they're performing. So, I mean, definitely manufacturers will have to be able to, from a technical perspective, be able to handle. And if you can handle more than one program, if I'm the consumer and I may benefit more by being part of a VPP, then that's where I should go. Don't ask me about the analysis for that. I don't know that we're there yet. But if I, based on my operation, maybe dynamic prices is what would be right for me. And that's what was beautiful about the DRP, the dynamic rate project, where customers wouldn't lose. They got a shadow bill and they could compare the two rates and what best worked for them. So I don't know that there's one answer to all of it. It really depends on the customer, I think. And security and data, that's a whole panel that we could put together.
I'll briefly touch on just the data privacy issue and not the VPP issue, because my company provides VPPs. So I think we've gone through a huge evolution in data access, and currently sort of the standard is using OAuth for users granting access. And we have actually a ton of problems with users understanding and grasping OAuth as a process. Apple recently has launched the utility connection for PG&E as part of iOS, and they use you can use standard OAuth, but they also provide a secondary methodology to provide account linking using an email or a text message for authorization. So I think there are ways to make sure that we get user consent for data sharing. And there are ways to do it that kind of meet users where they are. And I don't think it's a one size fits all like answer. But for sure, transparency in data privacy rules and I think regulation associated with how we manage data and how we share it and what users have access to is really, really important. And California does have, I think, good data privacy laws and is leading the way in the United States. Go California. And so, I think more of that. We'll see more of that. And I think it's really important that we all ensure that we're taking data security and privacy as an important feature.
And I'll just add on top of what they've already said with regard to standards and how we're standardizing around data privacy. The CSA, I didn't actually mention it earlier, but also has a data and privacy work group. So the same companies that are working on a lot of these other standards are also looking at data and privacy and how can we standardize a method for making sure that we're all doing it the same way and in an ethical way.
So now I am certain we are out of time. So thank you much for your time and attention, and please reach out with questions and comments.
Well, thank you for taking my last question there. I think those are really important. We could spend an hour on this. So our next session. So first of all, thank you to our speakers. Thank you for joining this session.